Hey, Topping Life Math and History, and we're gonna take a look at the zero product with trinomials. So, to start out the video, we're gonna do some sort of mystery lesson, and we're gonna build upon that to see what this is going to be looking like, or what's going to happen. So, our mystery problem is, when can these equations be equal to 0? So when would happen if a plus b equals 0? And what would happen if these two expressions would equal to 0? What could be filled in for x? What could be filled in with a and b, or either? Well, what we can do with the first problem, a plus b equals 0, what we could do is we can write 0 and 0 representing a and b. Or we can say 9 minus that by 9 is going to equal to 0. So anything a and b could be the opposites of positive and negative, or 0 to 0. With this scenario, for example, x plus 1 and x plus 7, what needs to be here is we gotta simplify this out. What we're gonna do is, since that there are two expressions not including the 0, we can write x plus 1 equals 0, and we can also write x plus 7 equals 0. So x plus 1, subtract that by 1, subtract that by 1, subtract this by 7, subtract that by 7. So we have x equals negative 1, or x equals negative 7. And what we just did is we tried to find what the variable is if we wanted the expression or the equation to equal 0. That is what the zero product is, when you try to find an equation with a variable when it happens to be 0. But what happens if we try to do it with a trinomial? So what we're going to be doing is not only using that zero product strategy, but we're going to do that with trinomials and find out why we do that with trinomials and why we do that. So right here is an example of a quadratic trinomial, because we're using the number 2 as an exponent and there are 3 objects on the field. But in this case scenario, we're going to use the zero product with the trinomial. And not only about this quadratic trinomial, it has a y. Going back to the previous videos, we have been taking a look at y equals mx plus b stuff, or slope-intercept stuff. But y equals x squared minus 6x plus 8 is a different story. When we try to find the two factors that will bring you to x and find out what x represents, we have to turn that y into a 0. So what we're going to do is rewrite the problem as x squared minus 6x plus 8 equals 0. If you put it on the right-hand side, it's easier to understand and it's easier to do the math. So after you write 0 right there, the next step you gotta do is actually factor out the trinomial. Ignoring the 0, you have to factor x squared minus 6x plus 8. When you find the two binomials, you'll be able to find out what x is when you have it equal to 0. So let's use the diamond problem, because x squared as a equals 1. So the diamond problem, we put 8 up here and negative 6 right here, because c on the top, b on the bottom. So 8 and 6, what two numbers multiply into 8 and add to negative 6? Well, we can put 2 and 4, because 2 multiplied by 4 is 8. But how do we get 2 and 4 to negative 6? hold on. A negative times a negative is a positive. And a positive and a positive is also a positive. Which means we can put these as negative 2 and negative 4. So what we can do to rewrite the equation is x in parentheses minus that by 2 and x minus 4 in parentheses. If you ever try to fact check out the problem, because these are the factors, it will bring you back to your quadratic trinomial. So we have factored out this quadratic trinomial. Our two binomials are x minus 2 and x minus 4. We have did it, but hold on. We are not quite done yet because just factoring them out isn't really the entire process. What we have to do now is use the zero product. So now we have to put these into equations of 0. Meaning we can rewrite them saying x minus that by 2 equals 0. And we can also say x minus 4 equals 0. Let's try and simplify. We add this by 2, add that side by 2, add this side by 4, add that side by 4, and we will get an answer of x equals 2. Or x will equal 4. So we will always be getting two values for x when we try out the zero product with trinomials. But why do we always get two variables with two different numbers? Or why do we get the same variable with two different numbers? Well, when you are working with quadratic trinomials, your math teacher may have taught you the quadratic standard form, and that happens when you have this equation, ax squared plus b plus c. Ax representing the x squared, b as representing the coefficient and the x, and c as a normal regular number. For example, we can write it as 2x squared plus 10x plus 22. That is one of my favorite quadratic trinomials. There's actually one more reason why we use the zero product when we try to find the two numbers. So, in the last video, when we were talking about parabolas, we have been looking that a parabola is able to have two x-intercepts. The x-intercepts represent where the 2 points from the parabola that strike through the x-interceptor, strike through the x-axis. You are always going to be having an example of 3, 0 as a point x, y, or an example of negative 3, 0, and x, y. So basically, it would be here because of the x-axis. So, what we just did right here, when we tried to use the zero strategy and factor it out to find two numbers for x's, what we are doing is proving why a parabola or an equation of x squared is able to have two x-intercepts. So here and here. We found out without graphing this equation that turns into a parabola and finding out its x-intercepts. Well, two x-intercepts. Let's see that on an actual graph and see if we got that correct. So on the graph we just showed you, we had an example of something that looks like this. And we had 2 right here and 4 right there. 2, 0 as a point and 4, 0 as a point as well. Those are the x-intercepts, which means without totally graphing the parabola, we have algebraically proved the parabola's 2 x-intercepts. And that is why we understand this math video and why we use the zero product with trinomials. With this algebra trick, you can graph and you can find the x-intercepts of any quadratic trinomial. I hope this video has helped you. Thank you for watching Cal Penguin Math Industry. Like and subscribe!